Hello, and welcome to the lesson number 4 of our NVIDIA Omniverse basic training. In the previous lesson, we learned how to build a robot from scratch in Isaac Sim. In this lesson, we will do something similar, but first we are going to learn about URDF files. URDF stands for Unified, let me check, Unified Robot Description Format, which is an XML-based structure used in ROS and ROS2 to describe a robot's physical configuration. The main elements on a URDF file are links, which are rigid bodies, joints, which are connections between the links, visuals, which are just the 3D geometry for rendering, so the visual representation, but it's only that, visual, doesn't affect the physical world. Collisions, which are the geometry for physics simulation that will affect. Then we have more things like inertial properties, coordinate frames, and anything related to how our model interacts with the physical world. Then we will see how do we import the robot from a URDF file into a USD format. We will set an environment for this robot, and then we will add some sensors as we did in the previous lesson and a differential control. After that, we will create a new file and we will import a predefined robot from the Isaac Sim assets library. So we will see how a complete robot looks like with all the sensors and all the joints and articulations, everything predefined, even materials with their specific properties. So let's do it. I have already downloaded the Carta URDF asset. I'm sharing in the description of the video the link to download this robot, and I have opened the URDF file into my VS Code or any text editor, so you can have a look to the structure of the model. The first tag is a robot tag, which identifies this file as a robot. Then we have the links, as we explained, visuals. I recommend, and if you are curious, you could just copy paste the whole file into ChatGPT, and ChatGPT will be very happy to explain with every detail what we have here. But basically, we will get a project tree in our stage in Isaac Sim, similar to this tree project, and we will see how we do that. I have also shared in the description of the video this link, which explains how the extension to import URDF files works, and you can see all the details. In previous version of Isaac Sim, that was like a kind of separated extension. Now, if we go to File, Import, and you find a URD file, you will have this extension in this side of the window. Let's do it. Okay, here we are in my Isaac Sim application. Let's go to import the robot. So let's go to import, select the Carta URDF file, and here we have a few options. First one, we are going to create it in a state. I don't want to have references within the model. Then we change to movable base. Static base is for static robots. Basically, if we select static base, we'll be adding a fixed joint in the robot that will be gluing the robot into the floor. Then for drive type, for the wheels, we select velocity, and for position, we select none. Collision from visuals, no. Allow self-collision, no. So that's it. Let's import it. Now we have our robot on the state. Feel free to compare the stage tree with the elements in the URDF file, and you will see which is pretty much the same. Now if I click play, the robot has physics, but we don't have a floor, so the robot would fall and fall until the end of the days. And then what we have to do is to create an environment, which is a flat grid. You don't have to do that, but feel free to hide the lights of the environment. If we select the robot, we move it a bit above the floor. Okay, and now if you click play, the robot stays there. One thing, this cube that you are seeing here is not the visual of the robot. This cube is the collision box. So we are going to hide it. It doesn't affect in anything, so we are not deleting the collision, we are just hiding the visual of the collision. And we are going to do the same for the wheels. So we're hiding the cylinders of the wheels. And the pivot as well. Hide. Please note that this is representing a cylinder, even if it's not a perfect circle, but that will also always depending of how many points you are importing to define the cylinder, but it doesn't affect the behavior of the robot. That one. Okay, so this is our robot. One known issue in this robot is that the articulations, the root articulation has been created in the chassis prim, which is incorrect because it will be created in the parent prim, which is Carta. So if we select chassis and we scroll down to articulation root, let's remove this. Yes. And we are going to add the articulation root into the Carta prim. Add physics articulation root. Now everything is correct. You can have a look to the joints to see how they have been created or imported. As you can see, the left wheel and right wheel are revolute joints and they are rotating within the y-axis. For the rear pivot, you can see it's rotating through in the z-axis. And if we click play, should not be moving. 1 second. Important. When I created the root articulation in the carta, we need to disable the self collision. Now it's not moving. Perfect. Now if you go to the joint as we did in the previous lesson, and we go to the drive, select 20 for the target velocity and the same for that one. You can use the search box to find items in the properties. And now if I click play, we can see the robot is moving smoothly. Now let's go into add the differential controller. That was in utilities, no, tools, robotics, Omnigraph controller, differential controller. As robot prim, we add the Carta robot, wheel radius. In the previous lesson, we built it ourselves. Now we need to find out what is the radius. And to do so, I'm going to select the cylinder of the collision and scroll down, and we can see that the radius is 0.24. And for the distance between wheels, we select the parent prim of the left wheel link. We can see that in the Y is 0.31, and for the right one is minus 0.31. So without being very picky with the decimals, the distance between wheels will be 0.62. For the joint names, joint, for the left one is that one, for the right one is that one. And we use keyboard control. Okay, so now we click play. When we use the keyboard, it's moving, but it's a bit too fast. So to fix that, let's go down to the graphs that we just created, differential controller, and max linear velocity 0.5, 0.52. So before doing that, I want to show you, if I click play, you can see here the velocity command, the outputs, and you can see that it's going from 0 to 20, which makes the robot that's working incorrectly or having a strange behavior. So let's set the max linear speed and max wheel speed to 0.5, and now you can see that this is the velocity output. Okay, and now we are going to add the LiDAR sensor and the camera as we did in the previous lesson. So we are going to add the camera to represent the RGB sensor. The front is in the other side, so we rotate the camera 180 degrees. I'm going to hide the git of the camera, the gizmo, and we are going to put the camera in theory This is the camera, and if you want to test the camera, we just move it here. This is how the robot is looking at the world. And the two-dimension LiDAR sensor, we create sensors, physics LiDAR, rotating. Where is it? We are going to attach the camera to the chassis, so it will move with the chassis as well. And where's the LiDAR? Didn't I create it? Hmm. I have errors. I don't know where the LiDAR are. Ah, because I had the camera selected. I need to remove that one. So this is the LiDAR sensor. And the LiDAR sensor should go here on the top. So for this robot, this cylinder here is representing the LiDAR sensor. Now we click play, nothing happens. You cannot see the LiDAR working because we need to allow these two properties in the LiDAR. Draw lines and draw points, and that's it. If you can see these red lines, it's because the LiDAR is it's rotating in the wrong direction. Interesting. How is that possible? Because I added. Let's go to add it directly to the world. Will be easier. And then I attach it to the Carta or to the chassis. Yeah, now it's fine. And if we move the robot, the LiDAR sensor and the camera is moving with the robot. We can see both. Now we are going to add some obstacles to see how the LiDAR is interfering with the environment. Like, let's create a cube here, and then we need to add physical properties to the cube. Yeah, so you can see the red lines because the LiDAR sensor is detecting the cube. Beautiful. Now in the next section we will import a robot from Isaacsim assets. Let's go for it. Okay, so I created a new environment and I'm going to import. If you go to Isaacsim assets and you look for Nova, the first one, you can pick and drop, and this is a evolution robot of our Carta robot, but this Nova Carta is coming with a set of uh, materials, so we can go closer and you can see that the wheels have material and we have some colors because they are using materials with their properties. Let's set up an environment here, environment a flat grid. I'm going to hide the lights of the environment because I like it more like that. It's already above the floor, and if we click play nothing happens, but everything has physics. So we have done that just so you can research or investigate about all the elements of this robot. It comes already with materials, with specific properties. We have all the joints. We have an array of sensors in somewhere. Let's expand. Oh, we don't have sensors here because this one doesn't have sensors. Just this link. Yeah, here. Sorry, it's been a long time. So here we have an array of sensors. We have two LiDAR sensors, two-dimensional sensors. We have an XT32, which is a three-dimensional sensor, which will create a 360 degrees scan. And we have four Hawk sensors, one in each side of the robot. These are stereo sensors, which will create a 3D dimension surrounding understanding for the robot. Just feel free to have a look on all this, and I will be sharing this link in the description of the video as well, which is pretty useful, with information of all the robots that you can import from Isaacsim. Well, this document is for the Isaacsim 4.2, so some things might have been changed, maybe some robots have been deprecated, maybe some robots are new, but most of them will be available in your asset store in Isaacsim. So this is for you to practice, and you can test it, you can add elements in the stage and see how this robot works.